Students, we're almost at our end. There is one more lesson for us to do, and it's our smart contract and security auditing for developers. Do not leave this course without watching this. I want you to have at least the fundamental knowledge of where you should look for security help, what you should have in mind for security, especially now that you have the ability to go out and deploy some amazing contracts. I'm not going to teach you how to audit step by step here, right? But I am going to teach you, here's what you should be looking for in an auditor. Here's how you can begin to start thinking about security. And I am working on some security and auditing education material as well to make those of you who do want to go down that path successful. So give yourself a pat on the back, do a little dance, do a little celebration, get some ice cream, and I'll see you in the next one. And then I will release you to the world. So pause the video and I'll see you soon. And as a special piece of bonus content, we have Harrison here to give us some tips on gas optimizations. So enjoy.
Hey guys, I'm Harrison Legio, and I'm the CTO and co-founder of Pop Punk LLC, where we're building Gaslight GG. Gaslight GG is a audit firm, but we focus specifically on gas optimization for protocols to ensure that your gas costs are as low as possible. In addition, we're happy to announce that we're now building hyper-optimized public goods tools for EVM developers to make sure that everyone has access to just the best and the cheapest contracts. So Patrick invited me on here to show an example of some common ways that you might be using too much gas in your smart contracts without really noticing. So I have a quick example here. We're going to look at an airdrop contract. This is a super basic airdrop contract, which I'm calling airdrop bad or bad airdrop. Very simple. We have a token. We're using a counter to iterate and count the number of transfers. So as you see in the constructor, we set the token here, and then we have our airdrop function. So we have two parameters for this function. The first one is a memory array of addresses, which is the recipients, and then we have a memory array of UN256s for the amounts. The first thing we're doing is we're checking to make sure that the amounts match, otherwise we're going to revert. The next thing here, which is really common, is making sure that you're batching your actions. So if we see in this case, we have to traverse through the entire input argument array a full time just so we can transfer the number of tokens from the message.sender to the contract. So let's say there's 50 amounts, we'd have to do 50 separate transfer froms. Definitely not ideal. And then lastly here, we have a super basic loop where we're just iterating through the array and we are transferring the tokens from the contract to the user with the respected amounts here. Lastly, we can see that we're iterating this counter every single time in the array, or every time in the loop, yeah. So keep that in mind. So now if we look at a more ideal example of this, the first thing that you're going to notice is we're using a mutable for the token. A mutable is good if you're obviously never going to change something because we set this value in the constructor and it'll be included in the contract deployed bytecode, which is cheaper to read from every time. If we look now here, we've changed our arguments for our function to call data, and we've added a new one called total amount. This is done so we don't have to do two loops through the array, we can do one. So if you see here, the first thing that we're doing is we're transferring this total amount from the message.sender to this contract. So that's going to cut a large amount of gas because we're only going to wind up looping one time. So if we see here, we've changed the way that we're going through the loop. Technically, we don't have to cache this array length because we're using call data. But if you do see here, it's the same thing. We're transferring tokens from this contract to the recipient. We're also using unchecked for our loop iterator because it's not going to overflow because the odds of someone doing an airdrop to more than the max UN256 of addresses is kind of crazy. And the final thing to look at here, we're using an unchecked block again, but rather than updating this state value of transfers every single time and paying that base gas cost each time, we can just update this amount at the end with the bulk length. So these are small things that you can think about when you're writing your smart contract to ensure that you're saving as much gas as possible. If we look at the results of this, the airdrop bad costs 1,094,690 gas. And the airdrop good costs 404,842 gas. So we've essentially saved 600,000 gas just by doing simple things. You know, it doesn't make the code unreadable, and you're just making sure that, you know, the end users of this will not have to spend a crazy amount of money. So I want to thank Patrick for having me on here. You can find me on Twitter at @poppunkonchain, or the business account is @poppunkllc. If you're a small protocol or a large protocol, feel free to reach out for gas audits, and pretty soon in the near future, you'll be able to go to gaslight.gg and you'll be able to deploy super cheap, super gas optimized smart contracts, through no code and just pressing one button. Thank you.